Hello, today's video is going to be on 1.7, solving absolute value equations and inequalities. So first, let's start off with what the absolute value sign looks like. It's two bars like this. An absolute value is representing the distance from zero. And one thing that's very, very important to always remember absolute value is that it's going to always be positive no matter what. When you evaluate absolute value, it's going to be positive. So the absolute value of 5 is how far away from 0 is it? It's 5 spots away from 0. Negative 6. How far away from 0 is negative 6? It is 6 spots away. Notice that this is positive. This just means it's 5 spots to the right. This means that it's 6 spots to the left, but it's 6 spots away. Absolute value is distance, so it's always going to be positive. Absolute value of 0, just 0. Alright, we're going to get a little bit harder. Now let's say we want to solve for what number inside would give me the absolute value with the answer of 5. I'm assuming most of you are like, okay, yes, 5. You are correct. The absolute value of 5 is 5. But there's another answer. What other value, if I take the absolute value of it, is also going to give me a positive 5? Hopefully you are thinking to yourself, ding, 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 it is a negative 5. If I took the absolute value of a positive 5, I get 5. If I took the absolute value of a negative 5, I also get an answer of a positive 5. So I have two possible solutions here, either a positive 5 or a negative 5. What number, when I put it inside, is going to give me an absolute value of a negative 2? So what number in here, when evaluated, will give me a negative 2 as an answer? Think about it. None. That is not possible. You may have thought, okay, well, the absolute value of 2, well, that's a positive 2. The absolute value of a negative 2, that's also a positive 2. When I evaluate these absolute value bars, the answer that comes out is always going to be positive. It's not possible to have a negative number there once the absolute value bars are isolated. Now it gets a little bit harder. We have an expression inside. I want to find out what value of x, when evaluated, will give me an absolute value of 15. So that means that if I'm going to do that this number inside has to end up being 15 for my answer to be 15. Or that number inside could be a negative 15, because a negative 15 will also give me a positive 15 as the answer. So I want to find out what value of x is going to make that expression a positive 15. And what value of x is going to make that expression become a negative 15. Because remember, either one, a positive or a negative 15 on the inside, when evaluated, is going to be a positive 15. We move that 3 over, and we get 18. We move the 3 over, and we get a negative 12. And we'll see 18 minus 3 gives me an absolute value of 15, which is 15. Negative 12 minus 3 gives me an absolute value of a negative 15, which gives me an answer of 15. So I see that both of these are going to work. Go ahead and press pause and see if you can do the next one on your own. Just remember, absolute value is always positive. So I'm looking for what value of x, when evaluated for absolute value, will give me a positive 9 answer. Go ahead and press pause. Alright, let's see how you did. Just remember that our answer in the end was a positive 9. So this expression on the inside could have been a positive 9, or it could have been a negative 9, because when evaluated, they both become positive 9s. So I find out what value of x is going to make that expression a positive 9, and what value of x is going to make that expression inside a negative 9. And if we plug both of those in, we will see that they both do work. Okay. Now we're going to move on to a more difficult topic, and that is absolute value inequalities. You should be familiar with inequalities, but you probably have never seen absolute value inequalities before. We want to remember a couple tricks. When solving absolute value inequalities, we have a less than and a less than or equal to sign. So if I have less than, this is going to be an and inequality. This is greater and greater than or equal to. So if I think about that, that's a greater. That's going to be an or inequality. So whether it's a compound and or a compound or inequality is going to be determined from the original inequality. And that's one thing, just less than sounds like and, greater, or. We want to always determine that from the first thing. That's the first thing I do when I look at it. That way I don't forget. So I look at this. I have a less than sign, which means that this is going to be an and compound inequality. So we have the absolute value bars. Remember that this quantity inside could be 11. It could be a negative 11. It's a little bit different than when we solve an equation. First, for an inequality, we write exactly what we see. We drop the absolute value bars. So 2x plus 7 is less than 11. We know it's an and. For our second one, we have two changes we have to make. Not only do we change that positive 11 to a negative 11, we also flip the sign from a less than to a greater. It's still an and compound inequality. That's why we say we have to determine it in the very first step, because we're going to have less than and greater than inequalities. So we go ahead and solve them like we would solve any other inequality. We move the 7 over. We divide by 2. Move the 7 over. Divide by 2. And we get x is greater than a negative 9. So now we have to go back to what we just learned about compound inequalities. We create our graph. We have a 2 and a negative 9. Make sure that you always put the smaller number to the left. X is less than 2, which means we have an open circle with our graph going to the left. X is greater than negative 9, which means we have an open circle with the arrow going to the right. Because it's an and problem, we are looking for the overlap. What do they both share? So our solution set is going to be right there. When we go to our next one, it's a little bit different. This is the first time that we haven't seen our absolute value bars isolated. We can't start solving them until that absolute value, until these bars are all by itself. I'm multiplying by 2, so my first step is to actually divide by 2. Now that I have those absolute value bars isolated, I can go ahead and set them up. The first inequality is written exactly the way I see it. Just drop the absolute value bar, so x minus 6 is greater than or equal to 4. Oh, what did I forget to do? I look at the very beginning. My first symbol is greater than or equal to. Greater means that this is going to be an or inequality. When I write my second one, I keep the x minus 6, I flip the sign, and I negate it, so that positive 4 becomes a negative 4. Then I go ahead and just solve normal. Move the 6 over, move the 6 over. Now we've got to go ahead and do our graph. Our numbers are 2 and 10. Make sure the smaller number's to the left. We've got greater than or equal to 10, close circle to the right. Less than or equal to 2, close circle to the left. And this is an or problem. Because it's an or problem, we are going to combine or recopy. So I'm going to combine everything from both sets into one set. And there's my or solution set. Okay. Here, again, our goal is to isolate those absolute value bars from the beginning. So the first thing I have to do is I have to subtract over that 6. And then I have to divide by the 3. I have to keep going until the absolute value bars are all alone. Then we set up our first one exactly the way it is. Oh, I forgot it again. Less than means that we have an and problem. So we've got an and. Our second one, we write the first beginning part, the negative x plus 5. We switch the sign and we negate. Now we go ahead and solve. We move that 5 over. When we divide by the negative 1 to make that a positive x, we are dividing by a negative, so we have to flip our sign. We move our 5 over. Divide by a negative, so we have to flip our sign. We have our graph. Greater than 3. Greater than 7. Oh, what did I do? Oh, I forgot to switch my sign. Knew something was wrong. So then open circle to the left. We have an and problem, so we're looking for that overlap. So here is my solution set. Next page. Turn that over. We're doing more solving. So when we look at this one, we remember that the first thing we do is greater than or equal to, which means I have an or inequality. I set it up. I've got 2x plus 6 is greater than or equal to 0, or 2x plus 6 is less than or equal to. Normally I flip and I negate, but 0 is not positive nor negative, so that's still just 0. We solve. We move our 6 over. We divide by 2. This time we do not flip the sign. There is a negative there, but we're not dividing by the negative. We're dividing by a positive 2. Move the 6 over. We divide by the positive 2. We go to graph. We notice this time we only have one number. It's just the negative 3. So we only have one number here on our graph. Greater than or equal to, close circle to the right. Less than or equal to, close circle to the left. Or means we're going to combine everything into one set. Our first set's negative 3 and everything bigger. Our second set is negative 3 and everything smaller. So between the two, I have covered all real numbers. So this is going to be a special case, one of those special cases that we've talked about. With that being said, why don't you go ahead and press pause and try the last one all on your own. When you're done, press play and check your work. Okay, the first thing that you should have done is realize that this is an and problem because we have less than or equal to negative 5. We set up the first inequality the same way, dropping the absolute value bars. The second one, we switch the sign and we negate, so the negative 5 becomes a positive 5. Then we go ahead and solve. So you should have ended up with x is less than or equal to 4/3 and x is greater than or equal to 14/3. We start off with our two main inequalities. Less than or equal to, close circle to the left. Greater than or equal to, close circle to the right. Now if this was an OR graph like we had on the front page, we would have just recopied. But because it's an AND graph, we are looking for the overlap. There is no overlap, so once again I have a special case, and in this case there is no solution. Alright, one last thing that I want to make note of is sometimes this can become very overwhelming with your absolute value inequalities. The best thing to do is to think about the problem before you hurry to an answer. Before you try to jump in and go ahead and do 10 million things, think about it logically, what makes sense. Once you have an answer, just make sure that it's actually possible. So when I look at this, can the absolute value of x minus 5 equal a negative 2? Is that possible? Without solving for anything, can I do that? The answer is no. Remember, when I evaluate this absolute value, that number that comes out of it has to be a positive number on the other side. Therefore, this quantity can't equal a negative 2? Can that quantity be greater than negative 2? Yes. Actually, that quantity has to be greater than negative 2 because this positive number, any positive number that I get out of here, will always be greater than a negative. Positive will always be greater than negative. Can that number be less than negative 2? No. Again, if it's a positive number, it has to be greater than negative 2. It can't be less than negative 2. If it was less than negative 2, it would be an even bigger negative number, which is not possible. Okay, and that is it for today.